All right, 2022, paper 1. Which of the following is a sketch of the locus of the point represented by the complex number that looking like z minus 5i is equal to 3? So mod of z take away open brackets. It's supposed to be a plus ib in the brackets, z take away. So a going to be 0. And we're going to have, in order to maintain the minus 5i, I'll have the plus 5i inside. So the center is going to be 0, 5. 0, 5 is going to be B. Yep, so the answer is B. The quadratic equation with roots 2 plus or minus I root 3. This was a repeat question. Directly as we saw it in the last paper, when we have the sum of the roots, when I add the two roots together, I'll get the 2 plus I root 3 plus 2 minus I root 3. So 2 and 2 is 4. So it's x squared, take away 4x. It's either this or this. When we multiply the roots, we are going to get 2 plus I root 3 by 2 minus I root 3. That's the difference of two squares. Square the first number, I get 4. Take away I squared. Root 3 squared is 3. 4. Take away negative 3, which is 4 plus 3, which is 7. So the answer is C. Z bar is the conjugate of Z. Which of the following is always true? So yes, 1 is always true. The conjugate of a complex number, the argument is not the same, all right, because the complex number will be in different parts of the complex plane. So Z bar is indeed real. So 1 and 3, the answer is B. The derivative of ln cos x over sine x. So we differentiate the function. Cosine x over sine x is going to be cot x. When I differentiate cot x, I'm going to get negative cosec squared x. And I have to divide by the function, which is cos x over sine x, which means I have to multiply by sine x over cos x. Minus cosec squared is 1 over sine squared. So the sine cancels with the sine squared. 1 over sine is cosec. 1 over cosine is sec. With the minus, we get minus sec cosec x. The value of, so far we are 5 for 5 in terms of repeats. Plug in the 4 using the Moivre's theorem. Cos pi plus I sine pi. Cos pi is minus 1. Sine pi is 0. Answer is minus 1. We are 5 for 5 for 6 for 6, sorry, for repeats. The gradient of the tangent to the curve, x squared plus y squared is 25. 2x plus 2y dy dx is equal to 0. dy dx is equal to, move the 2x, I'll get minus 2x, divide by the 2y, I'll get minus x on y, so minus 3 on minus 4 is plus 3 on 4, which is C. The derivative of cos inverse of x on 2 is equal to, note A and B are negatives. Okay, I don't know where that note comes from. It's just probably part of the document. It has nothing to do with the paper itself. When we differentiate cosine inverse, it's going to be minus the function, sorry, the derivative of the function over square root of 1 minus the function itself. So the function is x on 2. So when I differentiate that, I'll get minus 1/2 over root of 1, take away the function, function squared, sorry. 1 take away x squared on 4. So we had to do some work inside of here, right? We're going to get this is on the denominator. 4 minus x squared over 4, which is root 4 minus x squared divided by root 4, which is 2. So it's minus 1/2 over this, which is minus 1/2 multiplied by 2 over root 4 minus x squared. So we're going to get minus 1 over root 4 minus x squared. The answer is A. Next, if f of x is how much by? I don't even know what I look like. Anybody could figure out. I'm gonna make a guess, right? E to the x squared ln x. So f of x is e to the power x squared ln x. I can move this over here to get e to the ln x to the power of x squared. When I just want a derivative. Yeah, let me leave it like x squared ln x now. When I differentiate in this, I must differentiate the power, which is x squared ln x. That's a product rule. So we're going to get, this is u, this is v. It's going to be v multiplied by du dx plus u multiplied by dv dx. Fix it up. 2x ln x plus the x and the x cancels to give me x. That's the derivative. And we write back what the function is, which is e to the x squared ln x. So I want to say, so the answers that we have does not correspond to 2x ln x plus x. None of these corresponds to 2x ln x plus x. So I've seen here, they make ln x squared. So let's use some laws of logs and bring this as ln x squared. So the x remains there, and I'll get ln x squared plus plus x e to the x squared ln x. So does any have ln x squared x ln x squared? None has x ln x squared. So we had to factorize out the x now. So I'll get x into ln x squared plus 1, because it's going to be v du dx plus u by dv dx is 1 on x. Yeah, the x, right? E to the x squared ln x. So x e to the x squared ln x, because I multiplied these two together. And in the brackets are going ln x squared plus 1. So x e to the x squared ln x, that looking like this here and this here. But I'm looking for ln x squared plus 1, which is indeed E. Number 9, when I integrate in exponentials, I will differentiate the power. That is 4e to the 2x minus 1. Differentiate the power, and I'll divide by it. So I'll divide by 2. I'll get 2e to the 2x minus 1. 2e to the 2x minus 1 is D. Number 10, I will have to use the implicit differentiation with the product rule twice. So instead, because both powers of y are the same thing, I can solve for y. Rearranging 2x cubed y plus 6xy is equal to 3x. Y into 2x cubed plus 6x is equal to 3x. Y is equal to 3x over 2x cubed plus 6x. V and u is going to be v 2x cubed plus 6x by du dx minus u by dv dx 2x cubed plus, dv dx is going to be 6x squared plus 6 all over v squared, which is 2x cubed plus 6x all squared. Fixing up the numerator, I'm going to get 6x cubed plus 18x, take away 18x cubed, take away 18x. So the 18x and the 18x goes away. Minus, sorry, 6x cubed. Take away 18x cubed is going to give me minus 12x cubed over 2x cubed plus 6x all squared. They want to know the gradient when x is minus 1. So if I plug in minus 1 on the numerator, I'm going to get minus 12 by minus 1, which going to give me 12, positive 12 over, plug in minus 1 here, I'm going to get minus 2. Plug in minus 1 here, I'm going to get minus 2 minus 6 is minus 8. Minus 8 squared is 64. So 12 on 64. None of them corresponds to 12 on 64, you know. So the reason why we get a 12 on 64 using this method, now when we implicitly differentiate, we will get minus 39 on 8 to be the answer. But the reason why we get into different answers is when we are calculating the gradient at a point on a curve, that point needs to be on the curve. So in order for, well, not in order, let's take a look at the point where the curve is. This is the curve. This is the point. The point is not on the curve. So that's why using two different approaches, we would have gotten two different answers, because the point ain't on the curve in the first place. All right. So if we wanted a point on the curve, we will have to use the correct gradient. We will have to go ahead and plug in the x value into the function, which means implicitly differentiating is going to give us a wrong answer, because this point, we are using both the x and the y values when we are evaluating the gradient using implicit differentiation. But if I solve for y and I differentiate that, at the point when x is equal to minus 1, I will indeed get the gradient, the real gradient of the curve. So we got 12 on 64. Let me check and see what that is. 12 divided by 64 is 1.875. So let's check and see what the gradient at x is equal to minus 1 is. So x is equal to minus 1. Let me get what this point is. And I'm going to check and see what the gradient at this point is. So I'll get the tangent of the curve at B. Good. At B, let me hone in on which one. Well, one of these lines, 1, 2, 3, one of these lines is going to be with a gradient of 1.1875. So let's check and see which of the lines have that gradient. Right? Look at it, 0.1875. That's the line we're looking at. This could be a different gradient, and I don't know why we have so much tangents at B. I really can't see. Right? Probably because the function is kind of weird. Right? I don't know why. I suppose only have one tangent at B, but nevertheless. So yeah, the real answer is 12 over 64. But if we use the implicit differentiation, we will get a wrong answer, which will result in the minus 39 over 8. Right, and so be it. So yeah, to be careful with this, right? So I will say error. This point here is not on the curve. All right, number 11, the expression when written in the form a plus bi is that a square on top? I would like to say that is indeed a square on top, right? So the first thing I'm going to do, I'm going to expand out the 3. Actually, no, I'll leave the 3. That is a cube on top because I'm seeing 27s on the outside here. Cool. So I'm leaving the cubed. I'll leave the 3 cost like that. When I expand the cubed, I'm going to get 3 cubed, which is 27. And then I will distribute the cubed inside. So I'm going to get cosine of 4 3s are 12, cosine of 120, and plus I sine of 120. So what is cosine of 120? I know that cosine of 120 is going to be negative. So it's either here or here. Because 120 is in quadrant 2, in quadrant 2 only sine is positive. So I know either A or D is the answer. I'm going to check and see what cosine of 120 is. I'll leave it in degrees. It's negative a half. Even if I put it in, actually no, it is in degrees. Good. So negative a half, we're going to get A to be the answer. Number 12, given that dy dx is y squared minus 1, the solution to the differential equation can be expressed as, so we will, it looking like a partial fractions-ish set of answers here. So we are going to get dy over y squared minus 1 is equal to dx. So we had to break this up into partial fractions. All I'm going to do, I'm going to ignore the dy's and see which one of these 4 options gives me back 1 over y squared minus 1. So I'm not going to evaluate partial fractions. I'm going to check and see which answer gives me back my original question. So just for example's sake, how am I going to do the first one? 2 over y plus 1 plus 2 over y minus 1. I'll get 2y minus 2 plus 2y plus 2. I'm looking for 1 on top. I am not going to get 1 on top. All the denominators are the same for 1 and 2. So for the first one, I'm not getting it. For part B is a minus separating them. So I'll have a minus there. And I am still not going to get it. For part C, I'll get 1 over 2 into y plus 1. There's a plus. I want to say there's a plus in between them. Plus 1 over y minus 1. My denominator is, a 2 might cancel. I'll get y minus 1 plus 2y plus 2 minus 1 plus 2 and y plus 2y is 3y. No, I cannot get the denominator being y minus 1 into y plus 1 because I'll need a 2 to cancel with a singular number on top. Over here, I'm going to get 3y on top. No way 2 could cancel on top. If my maths is mathsing, process of elimination, D is the answer, but let's still check it and see. 1 over 2y minus 1, take away 1 over 2 into y plus 1. Cross multiply, I'll get 2y plus 2, take away 2y plus, when I expand out the brackets, 2y plus 2, I'll get 2y and 2y goes away. 2 plus 2 is 4. So I'll get 4 on top over, and when I multiply the denominators, I'll get 4 into y minus 1 into y plus 1. And the 4 and the 4 cancels. 1 over y squared minus 1. So the answer is D. Yes, it might be a lot maths, but partial fractions might have been the easier way. But this is just another avenue we can take to go ahead and solve number 12. The integral of 2x e to the minus x. This is a repeat question literally from the year before. I'll still do it again. This is u. This is v. dv, sorry. So v will be equal to minus e to the minus x. When I integrate, I'm going to get uv, which is 2x minus e to the minus x. Take away the integral of v minus e to the minus x by du dx, which is going to 2 minus 2x e to the minus x plus 2 the integral of e to the minus x, which is 2 by minus e to the minus x. Because when I integrate, no, it'll be plus, yeah, when I integrate, I'll get a minus, so it'll be minus 2e to the minus x. I'll get e to the minus 2 e to the minus x into minus 2 e to the minus x, x minus 1, minus 2 e to the minus x, sorry, x plus 1, plus c, the answer is A. Number 14, principal value of the argument of the complex number, right? Tan inverse of 2 over 2 is 1, that is pi on 4. This complex number is minus 2 plus this complex number here, so it's pi, take away pi on 4, which is 3 pi on 4. The easy answer. This is a repeat question. In a chemical reaction, the amount of substance A present at time t is modeled by the differential equation that A, B, K are positive constants, S is 0, T is 0. The expression for S in terms of T may be found by solving the equation. Just saying none of these answers will be correct because we have X's and Y's instead of S's and T's. But if we go through to integrate the S dt, we're going to have ds over A minus S, B minus S is equal to K dt. So when I integrate both sides, I'll get the integral between, I think all of the limits are going to be the same thing. So it's the integral of 1 over A minus S, B minus S. So the only thing that looks like that is going to be option B. A sequence is defined by U sub, I want to say n, it have to be n plus 1. U sub n plus 1 is 1 minus 1 over 1 plus U. The 20th term of the sequence is, so they say U1 is 1. Oh, this is supposed to be U sub n. If U1 is 1, let me get U2. U2 is 1 minus 1 over 1 plus 1. 1 minus a half is a half. So, once your maths in, this is a repeat question. U3 is going to be 1/3. U4 is going to be 1/4. So, therefore, U20 is 1 over 20. The answer is A. This is also another repeat question. We will get A to be 2. The second term will be a half. So T2 is a half, which will result in R being 1/4. And we want to evaluate the sum to infinity, which is 2A over 1 minus R, 1 minus 1/4, 2 over 3/4, which is 2 multiplied by 4 over 3, which gives me 8 over 3. Given that U sub n represents the nth term of a sequence, which of the following diverges? So the first one is alternating, right? It's harmonic, so it goes so up, down, up, down, up, down. So off the bat, this diverges, right? We can also test the limit as n tends to infinity of everybody, and if we get a number, it converges. If we do not get a number, it diverges. For this one here, for sure, as n tends to infinity, we are going to get something that's indeterminate. We're not going to get a real number. So the limit as n tends to infinity of the first one is going to be infinity. So he divergent. As the limit tends to infinity for this is actually equal to the constant e. All right. This here, as the limit as n tends to infinity for this one here, this one we will get a number. This is going to be, the denominator will be 0. We could use dividing by the highest power, or we can say we can differentiate top and bottom. To differentiate 2 to the power n might be a little bit of a stretch, but we have the formula that I would have shown you guys in a previous paper. Use L'Hopital. And for the last one, the e to the n is a constant, so this will be equal to 0. ln of 0, ln of infinity goes to 0. So the answer for 18 is A. Now I'm not too sure if this will come on all your current year's worth of papers, but let me hope it does not. And if it does, let me hope that this exact same question comes. Number 19. The third term in the power series expansion of that is 1 plus x to the minus 1 half. Alright, so this is equal to 1 plus minus a half by x plus minus a half into minus a half minus 1 by x squared over 2 factorial. So let me check and see what that is. Minus a half by minus 3 on 2 minus 0.5 multiplied by minus 3 on 2 minus 0.5 minus 0.75 divided by 2 is where's my last answer? 0.375 3/8 x squared. 3/8 x squared. The answer for 19 is indeed D. The sum of the first n terms of the series is this. The value of the second term is, so if we calculate the sum of the first term, that is the first term. So S1 is going to be T1, which is going to be, now it's supposed to have a summation there, right? I'm sorry, S sub n is equal to this, right? So when n is 1, again, 1 take away a quarter, which going and give me 3/4. S2 is T1 plus T2, which is 1 take away 1/16, which is 15 over 16. So when I take away S2 take away S1, that is T1. S2 take away S1 is going to be T1 plus T2, take away T1, which is going to give me T2. So 5 1/16 take away 3/4. So 5 on 16 take away 3/4 is minus 7 on 16. 15 on 16. What am I doing, boy? My bad. 15 on 16. 3 on 16. The answer is A. Alright, the coefficient of x to the power 4 in the Taylor series expansion about x is equal to 0 is, so f of x is cos x. F of 0 is, cosine of 0 is what? 1. But we want, I am concerned with this. I'm concerned with the fourth derivative. So f dash, first derivative, second derivative, third derivative, and fourth derivative is what I'm concerned with. To get the coefficient of x to the power 4 minus sine, cosine, minus cosine, then sine, then cosine. So when x is equal to 0, the fourth derivative at 0 is equal to cosine of 0, which is cos of 0 is 1. And we're going to have, for Taylor, we're going to have over 4 factorial f of 0 into x minus 0. F of 0 is 1 to the power 4. 4 factorial is 4 by 3 is 12, by 2 is 24. So we get 1 over 24. Answer is D. The sum of the infinite geometric series, A is 180, R is minus 60 over 180 is minus a third. a over 1 minus minus a third. 180 over 1 and a third. 180 divided by 1 and 1 third is 135. Answer is C. The coefficient of the fourth term in the expansion is... Alright, so... Okay. So we're going to get the fourth term, right? First term is 3x to the power 7 plus 7c1. 3x to the power 6, 2y to the power 1 plus 7c2. We're not concerned. There's 1, 2. There's the third one. The fourth one is 7c3. It's going to be 3x to the power 7 take away 3 is 4. 2y to the power of 3. 3 to the power 4 is 81. I'm not concerned with the variables, right? 81. 2 cubed is 8. And 7c3 is what? 7c3 is 35. 35 by 81 by 8 is 22,680. C is the answer. It's 35 we get for 7c3, right? Just making sure I have whatever I have right now, they correct. Good. The 10th term of an AP is 18, so T10 is 18. Common difference D is 3. The sum of the first 20 terms, we want S20. So T10 is, well, T sub n is A plus n minus 1 by D. 18 is equal to A plus 10 minus 1 is 9 by 3. So A is 18, take away 27 is equal to A. That is 9 minus 9. Right, me I want to be no hero. Let me just check and see. 18 take away 27. Minus 9, good. So S20 is equal to 20 over 2 into 2A plus n minus 1, which is 20 minus 1, which is 19, multiplied by D, which is 3. We're going to get minus 18 plus 19 by 3. 39 by 10 is 390, as I see. Using the binomial expansion, right, the cubed. Okay, so we go try to eliminate things off the bat, right? Let me see how the signs running for this binomial expansion. All I know, we do have to, I'm not going on bother to write the NC1, NC2, 3C1, 3C2, and so on. I'm just going to watch the signs for now. So I know that for the binomial expansion, I'll start with 2a to the power of the highest power. Then I have to add, these powers go down, and then the next power goes up, minus b, plus 2a to the power 1 minus b squared, plus 2a to the power 0 minus b cubed. So in terms of the signs, I'm going to have a 8a cubed for sure, right? So the answer is one of these three. From that, I'll have a negative number. So I know that u out of it, u out of it. After that, I'll have a positive number. Okay, so u in it, u in it. After that, I'll have a negative number. All right, so now I'm going to be more inclined to calculate what the coefficients are. All right, so I mean, I could see which one is the answer, you know. A cubed, then a squared, then a, then there this looking good. A cubed, a squared, a then. So C looking like the more viable answer, because the powers of B, they gradually go up. Over here, if I had a b squared here, it was good. So the answer for number 25 is going to be C. The values of x for which the expansion are valid. So we did this question already. I believe it was minus a half less than x less than a half. I can't remember. Let me check it over and see. So I'm going to get 100 minus 50x to the minus a half. I want to get this to be 1, so I'll factor out the 100 into 1 minus a half x to the minus a half, this whole thing. So this is going to be between minus 1 is less than minus a half, x is less than 1. Multiply everywhere by minus 2. 2 is greater than x is greater than minus 2. Flip it around with the signs, the answer is B. The sum to infinity of the geometric series, literally a repeat question, we get in 4a is equal to a over 1 minus r. R is a. Because a is equal to 0, I am allowed to divide both sides by a. 4 is equal to 1 over 1 minus a. Multiply. I'll get 4 minus 4a is 1. Rearrange. 4 minus 1 is 4a. 3 is 4a. 3/4 is the answer. Right, the value of n goes from 0 to n. Yeah. So a is going to be 1. R is going to be x. Oh, this was n goes from 1 to infinity. S infinity is a over 1 minus r. 1 over 1 minus x. Alright, Newton-Raphton. Alright, so we're going to get x plus the function e to the 2x plus 4x minus 5 divided by the derivative of the function, which is 2e to the 2x plus 4. Cross multiply, I'm going to get 2x e to the 2x plus 4x plus e to the 2x plus 4x minus 5 over 2e to the 2x plus 4. As seen in the answers we have, it was factorized. Alright, so let me factorize the e to the 2x. So I'm going to get e to the 2x into 2x plus 1 plus 8x is plus 4, right? Yeah. Plus 8x minus 5. None of them giving me 8x. When I differentiate that, e to the 2x, I get 2e to the 2x plus 4, right? When I rearrange, I get 2x e to the 2x plus 4x plus e to the 2x plus 4x minus 5. Oh no, my bad. It's a minus here. My bad. So we're going to get minus and plus 5. My mistake. So we minus 4x and the 4x goes away. And we're going to get e to the 2x into 2x minus 1. E to the 2x into 2x minus 1 plus 5. So 2x minus 1 plus 5, the only answer that corresponds to that is D. The coefficient of x to the power 11 in the expansion of 2 into a plus x. In this case, we only have one x term, so r is going to be 11. So we're going to have NCR, which is 12C11. I'm forgetting the 2, I'll go multiply by 2 afterwards. A to the power of n minus 1. NCR, a to the n minus r, b to the r. So 12 take away 11, and then we're going to get multiplied by x to the power 11. So 12C11 is what? 12C11 is 12, and we had to multiply that by the 2 to get 24A. Sample space X consists solely of 3 mutually exclusive events, Q, R, and S. If the probability of Q is 0.3 and the probability of R is 0.6, then the probability of S is, well, when I add up all the probabilities, I'm supposed to get 1. So 0.3 0.6 is 0.9, 0.9 plus 0.1 is 1. How many ways can 3 boys and 2 girls sit so that no 2 persons of the same sex sit next to each other? This is the only way we can do it. Arranging the boys, we're going to get 3. Arranging the girls, we're going to get 2 ways. Then we have 2 boys, then 1 boy. 1 girl, then 1 boy. This is 3 factorial multiplied by 2 factorial. Again, number 33 is a big mistake question, but I see to fix it. 3/10 is the answer for this one here, right? And let me provide the explanation over again. Was it 2021 that I did it over? Yes, it was 2021. So as this one is a little bit clearer, these are all the possible pairs of outcomes that we can have for the drawing the 2 cards, right? I am going to rule out 1, 1, because this says I'm drawing a 1, then I'm drawing a 1. The second outcome says I'm drawing a 1, then 2. That is possible. It's not possible for me to draw a 1 and then draw a 1 again, because the cards I have are labeled 1, 2, 3, 4, 5. I can't draw a 1 and then draw the same card again. So I'll eliminate 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, because those are impossible to happen. I'm not going to repeat the pairs. 1, 2 is the same thing as 2, 1. So I would have circled all of the possible outcomes. The rest that I didn't circle are repeats. Only 3 pairs of those possible outcomes, the product are primes. So, as a result, 3 pairs give primes out of the 10 possible outcomes. So I see that they did something very positive here. Fixed a mistake. 3/10 is the answer. Which of the following statements is true? This is a heavily repeated question, and the answer for it, for this particular one, is going to be D. There's one other variation for this, and I believe I would have done that prior. So once you all work all the way up the past papers, you will see which is a different variation we have for this. Over here, well, one time I am seeing a rows of zeros, which means this has no solution. Once you have a rows of zeros, then bacchanals happen, right? No solution. If we have a rows of zeros going over the augmented matrix, then something else happens. But we're not concerned with that right now. A high school dance class has 15 girls and 20 boys. 15 girls and 20 boys. A competition is held and awards are given for the first, second, and third place winners. 35 children in total. What's the probability that all 3 awards are won by boys? So if we have 3 awards, the probability that the first award, then the second award, and the third award, so we're going to say the first is going to be literally 20 over 35. The probability that the second place winner, first place already picked, so it will be 19 out of 34. And the probability that he's third is going to be, we're picking a boy again, 18 out of the 33. Multiply all the probabilities. Let's show you guys. 20 by 19 by 18. Divided by 35 by 34 by 33. 0.174. The answer is C. A team of 3 is chosen from 4 boys and 3 girls. How many ways can this be done so that the team has 2 girls? A team of 3 is chosen from 4 boys and 3 girls. So the team had 2 girls, right? If the team has 2 girls, we definitely just going to have 1 boy. So how are we going to choose that 1 boy? It could be any of the 1 boys. So we're going to say 4 boys, right? 4, choose 1. How are we going to pick the 2 girls? It's going to be, how much girls it is? 3 girls. And it has 2 girls. 3, choose 2. 3, choose 2. 4, choose 1. I know which one it is. I know if this is a 4 or if this is a 4. I know this looking like a 3 and a 3 and a 2 and a 2. So I'm just going to leave this on a blank. 3, choose 2 multiplied by 4, choose 1. The probability that a newborn baby is a boy is 0.4. What is the probability that in a family with 3... Oh, God, boy. Jesus Christ. So the probability of a newborn baby is a boy is 0.4. So the probability that a newborn baby is a girl is 0.6. What's the probability that in a family with 3 children, 2 girls and 1 boy? So 3 children could either mean like 3 births, right? Which going on be, first birth could either be a boy and a girl, second birth could be a boy and a girl, the third birth could be a boy and a girl. So let me draw a probability tree diagram. Boy, girl. 0.4, 0.6. So boy, girl. From here, boy, girl again. 0.4, 0.6. Boy, girl. From here, 0.4, 0.6. Boy, girl. So this is if you have 1 child. This is if you have 2 children. So 3 children go be the next branch of the tree. Boy, girl. Boy, girl. Boy, girl. Boy, girl. 0.4, 0.6, 0.4, 0.6, 0.4, 0.6, 0.4, 0.6. Alright, so what's the probability that 3 children, they have 2 girls and 1 boy? So let me go along the branches, right? 2 girls and a boy going to be a boy and then 2 girls. So 0.4 by 0.6 by 0.6. 0.4 by 0.6 by 0.6. Then we could have a girl and a boy. 0.6 by 0.6 by 0.4. And then we could have a girl, a boy, and then a girl. 0.6 by 0.4 by 0.6. So all 3 probabilities will be the same thing. So I'll just calculate 1 and multiply by 3. 0.4 by 0.6 by 0.6. Multiply this by 3. 0.432. Answer is D. Damn. 3 marbles are chosen without replacement from a bag. 11 blue, 9 red. So in total is 20 marbles in total, right? 11 blue, 9 red. The probability of getting a red followed by 2. A red marble could be 9 out of 20. And we're not replacing by the red. A blue going to be 11 out of 19. And our next blue will be 10 out of 19. 10 out of 18, sorry. Alright, so we multiply because it's looking at the and. 9, 20, 11, 19, 10, 18. The answer is B. Alright, number 40 now. From the letters A, B, C, D, and E, the number of three-letter words that can be made if no letter is repeated, that is, could be A, B, well, 3 letters, 5 ways, 4 ways, 3 ways, 60, or 5 pick 3. Right, this one is an elementary one. The probability that L occurs given that K occurs, that is L intersect K over K, 0.15, fix that good, 0.15 over 0.15 plus 0.35 minus 5 over 0.5. 0.15 over 0.5 is what? 0.15 divided by 0.5 is 0.3. 3 minus 4 minus 5, yeah. Oh, I'm looking at L. Is K I'm supposed to look at? 0.45 plus 0.15. 4 and 1 is 5 and 1 is 6 divided by 0.6. Alright, so please follow your diagram properly. 0.15 divided by 0.6 is 0.25. A is the answer. 42. Given that the determinant of M is 62, the value of X is... You had to go and calculate determinant here, no boy. You have no choice. Alright, so 2 multiplied by X plus 8, take away minus 3, go be plus 3, multiplied by 5 plus 6, that's 11, plus 1 multiplied by 20, take away 3x, this is 62, 2x plus 16 plus 11 by 3 is 33, plus 20 minus 3x is 62. I'm getting minus x is equal to 16 plus 33 plus 20. 69. When I move the 69 across, it becomes minus 69. 62 take away 69 is minus 7. So x is 7. M is singular. M is a singular matrix when x has a value of. So if the determinant is equal to 0, so we have the determinant, which is minus x. That is the determinant. When that is equal to yeah, so this is oh shucks, no. The determinant is minus x plus 69 is equal to 62. Right? So this is the determinant. So when that is 0, x is equal to 69 is going to be the value. The general solution of the differential equation. Alright, so this is going to be real and distinct. 0 and 3 are going to be the answer. So we're going to get a e to the 0x plus b e to the 3x. So we're going to get a plus b e to the 3x. Well, we have c1 and c2 as the constants here. So we have a constant plus a constant by e to the 3x. So a constant. So C is the answer. Alright, the displacement x of a particle, the particular integral x is. So again, this is a repeat question. One thing we have to look out for is if the complementary function has part of the particular integral in it. So when we solve this here, we are going to get real and distinct roots, and none of the roots going to give me a complementary function to be e to the power t. So the particular integral, x is going to be a e to the power t. The first derivative is a e to the power t. The second derivative is a e to the power t. Substitute this into my differential equation. A e to the t plus 2 a e to the t minus 5 a e to the t is 4 e to the t. Cancel all the e to the t's. I'm going to get 3 minus 5 is minus 2. A is equal to 4. And a is equal to minus 2. So x is equal to minus 2 e to the t. Alright, and that is it for, I can't remember, 2020